In problem number 14, we have the graph of a function f consisting of a semicircle and two line segments as shown above. If g is the function given by g of x is the integral from 0 to x of f of t dt, then the first thing we want to do is find g of 3. By definition, g of 3 is the integral from 0 to 3 of f of t dt, and so that's just the area under the curve between the curve and the x-axis from 0 to 3, and so that is a quarter circle of radius 2, so 1/4 of pi 2 squared, and then we have a triangle of base 1, height 1, so that would be area 1/2, and since that's below the x-axis, between the curve and the x-axis, but it's below the x-axis, that'll be a negative 1/2. And so we ended up with pi minus 1/2. And that is the answer for part A. For part B, we want to find all the values where g between -2 and 5, where g has a relative maximum. And g of x will have a relative maximum whenever its derivative g prime of x changes from positive to negative. And since g prime of x is f of x by the fundamental theorem, the derivative of the integral defined function from 0 to x of f of t dt is just f of x, so the derivative of g is f. In part B, all we're looking for is where f of x changes from positive to negative. At x equals 2, then x equals 2 is the only x value where there's a relative maximum. So that's where the only relative maximum value is going to occur. And that would be the answer and the justification for part B. For part C, we want to write an equation for the line tangent to the graph at of g at x equals 3. So for that, we need to know what g of 3 is, and we have that above as pi minus 1/2. So we need a point. We also need a slope. The slope of g at x equals 3 is g prime of 3, and g prime of 3 is just f of 3, and that is -1. So putting the pieces together, we get y minus g of 3, which is quantity pi minus 1/2, and that's equal to m, which is -1, times x minus 3. And that's going to be our answer for part C. For part D, we want to find the x-coordinate of each point of inflection of the graph of g on the open interval from -2 to 5 and justify the answer. Now, g of x has a point of inflection when the second derivative of g, or g prime prime of x, changes sign. Now, since g prime prime of x is really just f prime of x, and since f prime of x, the slope of the curve that you see there, changes sign only at 0 and at x equals 3, those are the points of inflection, or that the points of inflection occur at x equals 0 and x equals 3. And that's our answer for part D. And we'll go on to the next problem.